Are you curious how the seasons work on a flat Earth? Well, if you stick around, I think I can help. The first thing you need to understand is that the sun and the moon are close. They're within the Earth system and they circle around us. And I am going to show you with actual scientific evidence that not only do they circle us, but the sun changes its speed and its location where it rises throughout the year. Now, if you look at this beautiful sky clock overlaid with the flat Earth map, you can see that every 24 hours, the sun is doing a loop, which creates night and day, and the moon is doing the same thing, but about every 25 hours. Now, what the sun also does is it makes smaller circles in the northern hemisphere during our summer months, so June, July, August, September, and it starts to make larger circles and increase its speed as we move to winter in the northern hemisphere and the south moves to their summer because the sun is closer to them. And this is evident based on how long daylight lasts as the sun is setting. Now, like I said, there is evidence that the sun picks up its speed, which it would have to do to make larger loops. And this isn't just a theory. Like I said, there's evidence I'm going to show you. And not only that, but I'm going to show you evidence of the sun rising in a different location from month to month to month based on exactly what I'm saying here. What I quickly want to show you is that a general time-lapse photography video is about 30 frames per second. That's the standard. Now keep that in mind as I show you these next two quick videos. So this is the Mackinac Bridge in Michigan in the winter, clearly with the ice. And I just want you to watch how fast the sun sets because it's moving faster in the winter months and how fast the daylight goes away. Real fast. Now, same bridge, very similar location. The sun is starting in a very similar location. And this video takes about 3 minutes in the same time-lapse speed. And I'll wait here for a second and you will see the sun sets extremely slow in the summer compared to in the winter months when it has to be moving faster to make those larger loops around the flat realm you live in. I'm going to stop it here and skip ahead a little and you'll see the daylight slowly goes away instead of the winter when it's gone in an instant. Now again, I'm going to let this just play for a second, but I want you to think back to winter times. When the sun goes down, it gets dark real fast. And in the summer, when the sun goes beyond the horizon or to the vanishing point where you can no longer see its light, the light from the sun still lasts because it's moving much, much slower. And again, just to compare that to how quickly it sets here. Watch how fast this is moving in the wintertime. Same time-lapse speed. This video is 17 seconds. The other one's 5 minutes. Dark. Okay, so what I want to do now is show you the location of the sun and how it changes from month to month based on its rotation around the flat realm. Now, this is November. That direction is south towards Chicago, and it's right above the scoreboard. So remember, above the scoreboard, November. Now, it's not above, it's December. It's gone further south, like it does until the winter solstice, where it'll continue to go and then start coming back. Okay, so it's January now. It's hit the winter solstice. It's raised over there, and now it's starting to make its way back north. So February, it's now north of the scoreboard. March, it's further north of the scoreboard because now it's starting to head towards summer, where the sun is going to be circling the northern hemisphere at a much closer position. And now we're in April. You can't even see the scoreboard because it is raising so much further north, starting to warm up the northern hemisphere. And by northern hemisphere, I mean closer to the north. Not on a ball, but on the flat realm, north is in the center. So the sun is getting closer and making smaller circles around the North Pole. So like I said, I wanted to give you some observable, scientific proof that what's going on above us is different than what they say. And just because we've all been programmed to see things a specific way doesn't mean it's the right way. In fact, when you look at this model, it makes 1,000 times more sense. And you can make sense of it in your head based on what you observe every day.